So I appreciate majority of you in here have met differentiation before. I'm not quite sure where everybody's at, so I just want to kind of revise it and just sort of make sure that everybody's at the same point. So I'll just give you a quick introduction. I won't give you the full introduction that I usually give to differentiation. But can anybody tell me what is differentiation? What do they understand by differentiation? So if I say differentiate something, what am I asking? Okay. Well, I mean, it's to do with something that we are already familiar with. It's to do with a rate of change. Now, obviously you appreciate there's different sort of areas of maths. So for example, geometry, okay, would be the maths of, well, the maths of what? Drawing, yeah, good. So it's the maths of sort of shapes and yeah, exactly. And sort of visual constructs, right? If I said to you probability, what would that be the maths of? Chances. Yeah, good, absolutely. So it's the maths of chance. So if I said to you differentiation, what would that be the maths of? Differences, okay. So if it's a difference, then are you happy that it's the maths of change? It's things which change, right? So differentiation is all to do with things that change, and it's looking at the mathematical kind of properties of those things, right? So really, it's talking about the rate of change. So what do I mean by rate? What do I mean by rate?
The constant value?
No, and that's the reason why I'm not interested in constant anymore, because it's changing, okay? It doesn't have to be constant change. So if I say rate to you, what does that mean? It's to do with time, right? It's to do with how quickly something is happening. So really, differentiation, if I had to sum it up, is to do with how quickly things are changing, okay? And it's looking at the mathematics of that. Now, if you think about it, Archimedes, you said it's to do with constant. Now, there is a very specific example that we look at when we're dealing with constant change. So when we're dealing with constant change. In fact, we've already looked at it. What do I mean? What am I looking at if I'm dealing with constant change?
Same value repeating over.
Okay, so for example, I could give you something like this. I could say, for example, if this is time, and this would be the amount of money that I have, okay? I could say that after 1 year, I have, let's say, £2 in my bank account, okay? And then a year later, so 2 years now, I would have £4 in my bank account, okay? So 1 year, I have £2, and then after 2 years, I have £4. What would my rate of change be?
2.
Okay, £2 per
year.
Per year, okay. And then let's suppose, for example, a year later, so 3 years now from when I first invested my money, I now have £6 in my bank account, right? So now I have £6 in my bank account. Now, if I was going to draw these lines together, if I knew that my change was constant, what would I be working with?
A line.
Yeah, but specifically, what type of line? Sorry? Yeah, a linear line, a straight line. Yeah. So basically, if I'm dealing with constant change, I'm dealing with a linear change, okay? In fact, what would my change be? It would be £2 per year. What property of this graph, what property of this line, gives me £2 per year? The gradient. Perfect. Okay? So really, we've already met this concept. We've already met this concept of rate of change. It is literally just another way of saying gradient. Okay? Is that okay with everyone? Yeah, it's to do with gradient. So why then is this given its own name in the concept of coordinate geometry, and then suddenly we're talking about something completely different? We're talking about differentiation. What's different about this and what we're going to move on to?
That one has a curve.
Ah, good. So this one is dealing with constant change. It's dealing with a straight line. This is easy because the change is always going to be the same. The gradient is always going to be the same. But then the question is, well, what happens if the change is not the same? For example, I mean, it could still be time against money again, but let's say, for example, that the change is happening something more like this, okay? Change is happening something more like this. So as I move through time, the amount of money that I earn is changing at different points in time. For example, the difference between this point in time and this point in time would be different between the change of this point in time and this point in time. Is that okay? Yeah? So really what differentiation is about is still talking about rate of change, but it's talking about the rate of change of non-linear objects. Okay? So my question is, well, how on earth do we find the rate of change? Now, first of all, are you happy that the rate of change is different at different points? So, for example, over here, I mean, if I draw the gradient in at this point here, something like that, right, that would be very different to the change which is happening at this point in here. Okay, so which one is faster, this point or this point? Point on the left or the point on the right? The point on the right, yeah? Because for every movement in the x direction, you're moving more up in the y direction. Yeah? So it's still following this same kind of idea as gradient, but are you happy that the rate of change is quicker? Okay, it's simply got a steeper gradient. By the way, what type of line have I drawn in there? These red lines. What are they called? They're called tangents. Good. Okay? So we're dealing with tangents. Now, just remind me, what is the definition of a tangent? Okay, so you're dealing with trigonometry, fine. But in terms of the graph, in terms of a curve, what is the definition of a tangent?
A line that has one point. Yeah.
Good, so it touches the curve, and you said it right, at one point, and one point only. Okay, at one point only. So let's think about this in a little bit more detail.